Alright, let's continue further and take a look at example 9. This utilizes this distance one. So we're asked to find the distance between the parallel planes 10x plus 2y minus 2z equals 5 and 5x plus y minus z equals 1. So let's take a look at the solution here. First we note that the planes are parallel because they're normal vectors. So here's a normal one here, 10, 2, negative 2. And 5, 1, negative 1 are parallel. That is, they are multiples of each other. They're just multiplied over here by 2. So 2 times 5 is 10, 2 times 1 is 2, 2 times negative 1 is negative 2. Alright, to find the distance between the planes, we choose any point on one plane and then calculate its distance to the other plane. So we just need to find one point. Yes, for example, if you have two planes like this, parallel planes, for example, we just need to find any point here and then apply the distance formula to this plane. So we just have point here and then plane here, for example. Alright, so in particular, if we put y equals z equals 0 in the equation of the first plane, we get 10x equals 5. And so 1/2 0, 0 is a point on this plane, and we could see this. So if we look at the first plane right here, 10x plus 2y minus 2z equals 5. So we'll go plug in z equals y equals 0. So 10x plus 2y is going to be plus 0 equals to 5, like that. So we get 10x equals 5. In other words, divide this out. X equals 2, 1/2, like that. And then we're going to get the point 1/2 and then 0 and 0. All right. So we could apply the distance formula. So thus, by the distance formula, the distance between this point 1/2, 0, 0 on the first plane, and then to the second plane, and the second plane 5x plus y minus z equals 1 equals, this is minus z equals 1, not equals 0. Equals 0. No, actually, no, this was correct, because what we did, what the calculus book just did right here is it just took this negative 1, this 1, and moved it over. So you had a negative 1. In other words, so we have this format like that. So that's going to be d. d is equal to negative 1. Alright, so let's just plug this into the formula. So we get d equals to, let's write this whole thing out first, ax1 plus by1 plus c z1 plus d, absolute value, over a squared plus b squared plus c squared. And it's going to be on this plane, 5x plus 5 plus y minus z minus 1 equals 0. So that means the a is just going to be the terms in front of the variables. So it's going to be 5, and then x1 right here is going to be, well, the point, on the first plane. This is the second plane, so we're getting a point on the first plane. That's going to be this right here, 1/2, 0, 0. So it's going to be times it by 1/2, and then it's going to be plus 1 there, b is 1, times 0. Plus c is minus c. Then it's going to be minus c, which is 1 times by 0. And then plus d, which is negative 1. Minus 1, like that. Alright, so we have all this. And then that's absolute value. And then divide this by the length of the normal vector. 5 squared plus 1 squared. And there's a negative 1, that's going to be plus 1 squared, like that. Yeah, but for completeness, you could put a negative 1 squared, same thing. Negative 1 squared. So what we end up having is 5 over 2 plus 0 plus 0, minus 0, this is going to be minus 1, like that. And then there's absolute value sign, but then 5 over 2 is bigger than 1. We can just remove that absolute value sign. So it's going to be like this. Square root 5 is 25, plus 1 plus 1, 27. So square root 27. And erase this. Yeah, this equals 2. Let's multiply this top and bottom by 2. So then, same common denominator. So 5 minus 2 is 3 over 2, like that. And then this part right here is interesting. So what I'll do is this 27, that's just the same thing as writing 3 times 9. And then we know that 9, square root of 9 is 3. So that means we could have a 3 over 2 over square root 3 times by 3. So then this cancels like that. And we're left with 1, yeah, this is going to be 1 over 2 square root 3, like that. And here my calculus book actually simplifies this even further. It doesn't like having a square root at the bottom. I'll show this over here. So what it does is multiply the top and bottom by square root 3. So then basically what we'll get is this part of here will be, the square root 3's will become 3. Like that. So this will become square root 3 over 2 times 3, which equals to square root 3 over 6. Like that. Alright, and now going further, we can calculate this out. So the distance between the planes is square root 3 over 6, which equals to square root, you can just type this out in the calculator right here, SQRT, or square root 3 over 6. And using my, again, OneNote calculator, space equals to 0.2886, etc. It keeps going on and on. It's pretty amazing. I built in OneNote calculator. Anyways, let's go further. So let's graph the two planes and calculate its distance using the amazing GeoGebra 3D graphing calculator. As always, it even has distances from planes. So here's the plane 1, 10x plus 2y minus 2z equals 5. And here's plane 2 in green, 5x plus y minus z equals 1. And calculate distance A, just type distance from between plane 1 and plane 2. It's just 0.29. Here's rounded up 288. Rounds up to 9. And there's two planes. There's the plane 1 is red, plane 2 is green. So notice they're parallel, and if you turn it around, you can see that they are indeed parallel, and the distance from here to here is 0.29. Absolutely amazing stuff.